in this lesson, we are going to cover chi-squared tests for homogeneity. So the question is the distribution of gummy bear colors the same for Haribo gummy bears and Black Forest gummy bears? Our class collected data to determine if we have convincing evidence of a difference. So given in this chart are the observed values from our data collection. And the first question is, how many samples do we have and where are they from? So we have two samples, the Haribo and the Black Forest. And how many variables do we have? Well, there's one variable and it is color. And now we need to write the hypotheses for this. So going back to the question asks to determine if we have convincing evidence of a difference between these two colors, these two gummy bear brands. So what we're going to assume for our null hypothesis is that the two brands have the same distribution. So that would mean that there is no difference in color distribution. And then the alternative is that there is a difference in the color distribution for the two brands of gummy bears. So once we have the hypotheses written down, we need to go back to the beginning and we need to fill in the margin distribution for the totals for each color and the totals for the brands. Let's fill that information in. Okay, once we have that, we're going to go down and create our expected counts. So the expected count is based on the idea that the null hypothesis is true. So we said up here that the null hypothesis is that there is no difference in color distribution for the two brands of gummy bears. So that would mean that they would have the same numerical distribution. So for example, if we had the same number of gummy bears, like 100 and 100, well, then we'd say, okay, well, maybe there's 20 and 20 for our red, and so on. But if you take a look at our actual observed data, we do not have the same numbers of each. We have only 64 Haribo and 104, 63 Haribo and 104 Black Forest. So these numbers in this chart are not going to be identical. What we need to do then is we need to say, okay, well, not maybe the same number, but they're going to have the same proportion. So what we need to do first is figure out what these proportions are. So to do that, the very first thing we need to do is we need to fill in the marginal distribution from the observed data. So now that we have that completed, we need to figure out what ratio, what proportion of red out of the entire piece. So the proportion for red is 51 out of 167. That's our total. Now, that proportion then, if I multiply that by the number of total Haribo gummy bears were used, that'd be times 63. That's going to give me my expected count for the Haribo red. This would be, and if we do that, we get 19.7, excuse me, 19.2. So that's going to happen for the entire chart. Now there's a formula that they use to help you with this. And here is the formula. To find each of these expected counts, you would take the row total times the column total and divide it by the table total. And in essence, that's what we did when we did this red calculation. So for the red, then it looks more like this. Using this method, it gets you the same answer, so the row total is 51 times 63 divided by 167. And then you could do the same thing for the Black Forest. It would be 51 times 104 divided by 167. And that gives you our numbers. Okay, go ahead and pause this video and complete that for the rest of the table. So here are the totals you should have for your expected counts for the color distribution for each brand of gummy bear. So hit pause and complete this if you have not done so. So let's work through the 4-step process for this significance test. So step 1 is the state step, which we're going to go ahead and restate our hypotheses as we stated on the front of the paper. And then we have a significance level of 0.05. Step 2 is the plan steps. The name of the procedure is the chi-squared test for homogeneity. And now we need to check our conditions. So just like with other 2-sample tests that we have done, we're going to need to check conditions for both samples. And these are the same conditions that we use for the goodness of fit test. So for random, we can say that both samples, we took random samples. Although it wasn't stated in the instructions, we can basically assume that we took random samples from both brands. Okay, so then we can check our 10% condition. Now, again, we're using 2 samples, so we need to check the 10% condition for both samples. So 63 is definitely less than 10% of all the Haribo gummy bears, and 104 is less than 10% of all the Black Forest gummy bears. Now this third one, large counts. So for large counts, what we need to check is that all expected counts are greater than or equal to 5. And you actually are going to have to write that and state that as your condition. So looking at the chart on the first page, down here, not the observed values, but in the expected counts, look in the middle there. Are all of those numbers greater than or equal to 5? Yes, they are. So what they want you to do then is identify the smallest, which is the 8.3. So that one gets identified and I am labeled on your conditions. So the lowest expected count is 8.3, which is greater than or equal to 5. So that's our check. So we have to state both of those. Okay, then we get into the step 3, which is the do part of this. So we're going to start with the equation. So your equation is the chi-square test. Oh, excuse me, the chi-square test for homogeneity. It's our chi-squared is the sum of, and then we have our observed minus our expected. And the difference is squared. And then those get divided by the expected. And then we add those all up. So yesterday we did that in the goodness of fit test. And we showed all that in our table. Now you're not expected to show the entire table for this anymore. What we do want to do though for showing our work is we're going to show the first two data for observed minus expected, and then just we'll do dot, dot, dot. So I'm going to pause and put a couple of these on here. So if this was a free response question on the AP test, then you would actually go ahead and write out a couple of these like I have modeled here, and then just put the dot, dot, dot. The rest of this we're actually going to do in the calculator in just a moment. Let me discuss the degrees of freedom. So the degrees of freedom is the row minus 1 and columns minus 1, and then the product of that. So for ours, we have 5 rows, and we have 2 columns. So that gives me 4 minus 1. Oh, excuse me, 4 times 1, which just equals 4. So that would be our degrees of freedom. Okay, so to put this into the So to do this in the calculator, go ahead and get out the directions that I gave you on the first day of this lesson that has the directions for entering a chi-square test into the calculator, into the Inspire. And then also go ahead and clear your calculator. You're going to be using Scratchpad or Calculate page so that we can enter a matrix. So here I have the directions for the chi-square test for homogeneity using the Inspire. This is what's on your paper that you were given. And I'll kind of walk you quickly through these steps. I have screenshots on here as well. So you're going to go ahead and go to your Scratchpad and go to Menu, and you're going to create a matrix. The number of rows for this particular matrix is 5 because there's 5 colors. And our columns are 2 because there are 2 brands that we're working with here, 2 samples. So you're going to type in the observed values. The focus is on observed values. So get those typed into your matrix. Then double check it. This is really the only place you can make a mistake is typing the wrong number in here. Then once you have those entered into the matrix, you're going to go ahead and tab over so that your cursor is over here to the right side of the matrix itself. And then once you tab over, then you're going to do this step here that says control var, which is your store. And you're going to give it a name. Now, the suggestion was to type in OBS. I went ahead and gave mine the name of Gummy. It doesn't really matter what you name it. Once you do that, hit enter, and you'll see that it reappears over here as another matrix. So that way you know that it's done the correct thing. So it's stored the matrix now. Now, step 2 then is to go in, and we're going to go back to menu and go to stats, and we're going to run a stats test. And as you go through the menu selection, you'll notice that you get down and it says a chi-squared two-way test. That's what you want to test. When you get in there, it asks you where your observed values are located. So you're going to use the name that you gave it. So for me, mine was Gummy. So that's why I chose that there. Again, if you gave another name, you would tell the calculator where your observed values are stored. And then when you hit enter, it gives you all of this data. So it gives you the chi-squared, that's your test statistic right there. And then it also gives you the p-value. So it's done all of this work for you. Now, the other thing that's really nice is that it actually asks you, I'm sorry, it doesn't ask you. You can actually ask it to get your expected counts. So all of that work that we did on that calculating the expected counts on the first page, we did not have to do that. The calculator will do it for you. So to do that, you will go to where the VARs button is, VAR, and go ahead and look down the options on the menu until you find stat exponential matrix. And once you have that, hit enter, and then you have to enter twice, and then look there. It gives you the entire matrix of the expected counts that we calculated earlier. So this is a shortcut to getting there. Notice the AP test is timed, so you really don't have the time to go in and do all those separate calculations. You want to use the calculator to its fullest capacity. And you are going to have to show these expected counts on your paper. So now that we've done this calculation, we have our test statistic that we can provide. The chi-squared is 2.929. And then our p-value is 0.5697. And then we do need to write those and state them in our do step. And then our picture. So notice we are sketching a skewed right curve, not a normal curve, not like what we're used to sketching. The left-hand corner down here, that needs to be 0. And now we're going to mark our chi-squared test statistic. So it's 2.9. So like, where is that in here? Well, I'm going to cheat a little bit and know that the p-value is 0.569. So that's over half of the area. So somewhere maybe like here. Okay, just estimate where you think over half of it is. And so that would be labeled as 2.929. That's my chi-squared test statistic value. I'm going to give this a name, chi-squared. And my degrees of freedom are 4. So that's going to be labeled on the name for this. And then the shading is going to be always to the right. And you're going to shade in that section of the graph. And then our conclusion is stated the same way that we have done the previous conclusions. And so I will write it out and hit pause and bring you back in just a minute. So in conclusion, since our p-value is greater than our alpha level, we failed to reject the null hypothesis. Now, we're going to go ahead and state that there is not convincing evidence that, and then this is where you state the alternative hypothesis. But since our hypotheses are in sentences, it makes it really easy to write. So we would say that there is not convincing evidence that there is a difference in color distribution for Haribo and Black Forest gummy bears. So it's kind of awkward that we're saying that there's not convincing evidence that there is a difference, but that's the way we need to state this. And then lastly, it is asking us, we just wanted to kind of help you out here to see the difference between the two types of chi-square tests that we've talked about. So the difference between the homogeneity and the goodness of fit test, the homogeneity test had 2 samples from 2 populations, and the goodness of fit test had 1 sample from 1 population. They both had 1 variable, and in the examples that we did, we used color as that variable, but that's can be different. It can be different depending on the situation. Okay, go ahead now and complete the 11.1, check your understanding, and then also the 11.1 and 11.2 mixed practice.